In this video, we have the integral of the square root of x plus 1 over x. And normally this type of problem calls for a U-substitution. We could, let's say, u equal x plus 1, u equal to the square root of x plus 1. I always like to try letting u equal to the entire radical, because I get it out of the way if it works. So u equal to square root of x. I could find du here, but I think it'd be better if I just square both sides, get this, and then differentiate here with 2u du. The area of the right side is 1, or 1 dx. So I want to transform this integral into one involving the variable u. Obviously the numerator will be u, and from this equation here, I could let x, take the 1 over, let the x equal to, or the x will equal to u squared minus 1. Okay, so the numerator, that's your u. Dx is 2u du, right here. And the x is going to be u squared minus 1. So multiplying this side, we get 2 u squared du. That'll be over u squared minus 1. So now we have a rational expression here for the integrand in terms of u, but the degrees are the same here. So let's go ahead and use long division, I guess, in this case, 2u squared, and then divide this. So 2u squared divided by u squared minus 1. U squared into 2u squared will go 2. Multiply, that'll be 2u squared. 2 minus 1 is a minus 2. We subtract 2u squared, subtract 2u squared cancels. 0 up here, minus the minus 2 is 2. So I can replace this integrand then. The quotient here is 2. The remainder is 2. So this can be replaced by 2 plus, that's the remainder over the divisor. So this will be 2 over u squared minus 1. Then you can set this up as partial fractions here. The 2, no problem. Integrate that with respect to x, you're going to get 2. And actually, this is a du here. So 2 integrated with respect to u, of course, will be u. And then for the this part right here, the integral of this right here will be 2 over u minus 1 and u plus 1. That'll equal to partial fraction decomposition, linear factor, so we have a constant a over u minus 1. Another linear factor of u plus 1, so this will be b over u plus 1. You can set up a system of equations here, or you can use the cover-up method. So we want to find a. We look at the denominator. What makes its denominator 0? So we evaluate, cover it up over here. So the u minus 1 is covered up. And plug in a 1 there. Has to be 1, and 1 is 2. 2 into 2, so a is equal to 1. For b, it's u plus 1. So we cover up the u plus 1 now. What makes u plus 1? 0, negative 1, so we plug it over here. This is now covered up. The u minus 1 is uncovered. That's negative 1. Minus 1 is minus 2. And 2 is negative 1. So b is equal to negative 1. So we integrate with respect to u. So for the 2 there, this would just be 2u. And then this will be plus the integral of a over u minus 1. And a we know is 1, so this will be 1 here over u minus 1. It'll be plus, and then it's going to be b over u plus 1, but b is negative 1, so this will be negative 1 over u plus 1. So we got a constant in the numerator, 1 over here, negative 1 over here. Denominator, we have linear factors, and the derivative is 1. So this is easy to integrate. This is, again, of course, 2u plus, and then this is going to be ln of absolute u minus 1. But remember, u is the square root of x plus 1. So I have a minus 1 here. And then it's, again, got minus there, so this will be minus ln of the square root x plus 1 minus 1. constant of integration there. So to finish it, then I'll just come over here. This is going to equal to 2 times of this one right here, u, but u is the square root of x plus 1. And then it's plus the natural log of the absolute value of square root of x plus 1 minus 1. And then it's going to be minus, right over here, natural log of the square root of x plus 1 minus 1. Let me take this off here. So I'll have a minus natural log of absolute square root of x plus 1 plus 1. And then we've got the constant of integration. So we'll find our answer then. 2 times the square root of x plus 1 plus the natural log of the absolute value of the square root of x plus 1 minus 1. And it's minus the natural log of the absolute value of the square root of x plus 1 plus 1 plus the constant of integration. Thanks for watching. We'll see you next time.